Hi, Gary Mintchell here. This is episode 141 of Gary on Manufacturing. Today, I wanted to talk about the next 5 minutes on manufacturing strategies. How can you make manufacturing operations better? It's something that most of us want to do if we're in manufacturing. How can we streamline things? How we can be more efficient? How can we be more effective? And, mostly we've thought a lot about lean, and we've kind of leaned out certain things in the process industries where we do a lot of things with pipes, and we don't want a lot of intermediary tanks. As they told me years ago when I was exploring this, it's like, Gary, we leaned out a long time ago in the process industries. In the discrete industries, we still have some problems with one-piece workflow and work in process inventory. Way back in the 70s when I was getting my feet wet in cost accounting and all kinds of operations things. What a terrible thing that always was. It just tied up tons of funds. So anyway, how can we streamline things? How can we make things better in process, batch, and discrete manufacturing altogether, although we have different emphases? There are two main strategies going on right now in the world that I know of that are really looking at this from a holistic point of view, and how can we model things and analyze things, and the term is actually computation. How can we do a computation model, if you will, of manufacturing, and use it then to iterate back into our manufacturing operations and our management and so on, and make our manufacturing better. I was introduced to both of these, and as a disclaimer, one of them I worked with. I'm not officially a member, I don't think, but I work with the executive committee some. So, and that would be the Smart Manufacturing Leadership Coalition, pretty much instigated, I believe, by a professor at UCLA, and Jim Davis, and he's taken a look from his standpoint, and there's some other professors on board now, including Tom Edgar from University of Texas and several others. A lot of technology supplier companies involved, and also a lot of end user companies involved that have contributed enormously, because these are like director of engineering or director of manufacturing engineering, or that kind of level of person who's looking at operations and, how can I improve things? So we have smart manufacturing in the United States, and the Smart Manufacturing Leadership Coalition won a grant from I believe, the Department of Energy of the U.S. government, and so it has some funding from the U.S. government to develop test beds and so on. And then we have an initiative kind of in Germany, and the genesis of this, I believe, probably came from Siemens. Years ago, I used to talk to Siemens executives at the ARC forum in the wintertime in Orlando, and they described to me a vision they had of digital manufacturing. And the idea was that I design things digitally, and I can design all the way through. Theoretically, I can design from the part to the machine that makes the part to the line that manufactures the part. I can throw in the controls, so then I can operate this actual line digitally, and then I can figure out all these things. So I can get my manufacturing line optimized. I can get I can figure out the best mechanical designs. I can figure out my interferences and motions and all that kind of stuff before I ever start cutting steel and assembling stuff. And then later on, I have a model to go by to make sure either A, I'm doing it right, or B, how can I improve it. And so that's called in Germany Industrie 4.0 or Industry 4.0, and it means the fourth generation, if you will, of industry. And I can't go through all four of those right now, but anyway, it's a fourth generation of the way we manufacture. This is based on cyber-physical systems, which is actually based on the work of Professor Edward Lee at the University of California, Berkeley. However, there's a professor in Germany who actually also wrote a theoretical paper on cyber-physical systems, which is naturally the one that they quote in Germany. So anyway, so we have two things, and what are we doing? I've already laid the foundation for this whole thing. It's how can I model these things? So in Industry 4.0, we're actually looking at how can we model a whole line. Seems to be mostly discrete, or in Europe they would say factory automation oriented. But I believe they're trying to expand. Most German companies, every German company I talked to over the last 2 years, say, Gary, we already did this. So it's a good thing that Angela Merkel came up with this idea of Industry 4.0. We're already doing it. We're on board, with the whole thing, and that's okay. That's good. That we're all moving in this direction. It shows a trend, and so I believe that's an interesting thing, and I'm watching it carefully to see what goes on there. There's a little obfuscation maybe going on in terminology, because I have heard a couple of Siemens executives, Helmut Ludwig and Raj Batra, have both kind of talked about smart manufacturing in the context of Industry 4.0. And so terminology gets to be a little bit weird, and I've been trying to I'm a real bug on terminology, as many people know. So I've been trying to work on sorting that out so people don't get confused. So we have that work over here based on digital manufacturing, from the design of the part to the design of the machine to the design, and you can design the whole process. And so that's cool, and I've been studying that for a long time, and I'm glad to see it coming closer, and I think it will hold many, many benefits for the future of manufacturing of that sort. The smart manufacturing part of it, they're taking a whole different approach, and it's taken me a while to figure it out, partly because I got involved late. I wasn't an early person on the committee. I heard about it, and then had a person from Rockwell invite me in, and I've been involved, and I'm doing a little bit of writing and that stuff to help them out. But they're taking a look at it from the standpoint of workflows. So it's all they've got this concept, workflow as a service. You've heard of software as a service, platform as a service. This is workflow as a service, and so we can do a computational model of workflows. We study workflows. We send out maybe PhD candidates or postdocs or something, and just like my friend Jay Lee from University of Cincinnati does with the intelligent maintenance systems. So he's looking at that kind of thing. This is looking at from a different standpoint. Same idea. Let's study the workflows for these processes of this company. So we'll just take one. And there are several test beds working now. And if you go to smartmanufacturingcoalition.org, you can kind of catch up on all of this stuff. And so the modeling has begun, and we're the proof of concept. So we'll model the workflows. We'll do the workflows. We'll iterate kind of back and forth until we keep improving manufacturing. And workflows, you realize, can begin all the way back on the supplier side and then go all the way through to the customer. So all of it is just one huge workflow with a whole bunch of workflows in between as we do the work. So as we model that, then we can start, then every company can start looking at their operations and start figuring out their workflows and detail them, and then study them and do a computational model. And then they can start doing their management a little bit more rationally, with a little bit more understanding and a little bit more guidance toward where we're going with that. So basically, in a nutshell, and I didn't do either concept justice, but it's like just a few minutes. I just wanted to broach this, that there are two approaches. Don't get them confused. They actually are taking two different approaches, and they may not even be mutually exclusive for all I know, although I don't know if I can get my head around that. But if you're looking at your manufacturing operations, be aware that there's help coming that can help you expand to the next level, where I can rationalize my operations and I can figure out things from a model-based system. I can fix my model, and then I can fix my my actual physical operations, and then I can iterate and I can improve. I could try new ideas out in the model and then implement them. I can implement things then better, faster, cheaper, all that kind of stuff.